I'm Raluca Stanciu. I work at Bulgard in the antivirus team.
And I'm Cristian Guș. I work also in the antivirus team.
Okay. Today we are gonna talk about orchestrators, about microservices, about protecting sensitive data in the cloud in both hybrid and multi-cloud architectures. We have observed the context nowadays that companies apply complex architectures in their products, meaning that they start with one microservice and one Docker maybe on premises, and they end up in a few years having a high number of microservices scattered around maybe on multiple clouds. So we have decided to address the need of an overall image and deep dived at some points regarding how to protect your scattered sensitive data and secrets around a lot of places in the world. So today we have created a sequel of presentations. The first one today will picture a more general image of secrecy protection in the cloud with a slight of deep diving, and the next of presentations to come will deep dive in some focus points. Okay. Regarding secrecy in the cloud, we decided, first of all, how many of you at some point in your life have stored credentials for a database or something internal in a source code? Raise your hands. I don't believe you that you haven't. There are some here also. Well, we decided to see what we could find if we would scroll around public repositories on GitHub. And we did. We found a tool, an open source tool, and we decided to have it run for about a week and see what we might find in public source code. But we were surprised to see that we only had to wait for 8 minutes. You don't see it clear here. But the one with green are the tags of secrets in cloud. Access keys, username and password. The first one, there was username and password. You had client secrets. So it only took 8 minutes to find something in public repositories on GitHub. Okay. Some mismanaging of sensitive data in the cloud can lead to some consequences. Yes. We have Capital One this summer. I don't know if you know Capital One. It's one of the top 10 banks in America. They leaked about 106 million credit card details. They had them leaked. And their stocks fell from $100 to $85 in a short period of time, 15%. Let's say you have MasterCard priceless specials platform in Germany shut down this summer because somebody hacked it and they didn't use the proper methods of protection for sensitive data. And the MasterCard, official MasterCard, shut down the platform. And you have Shutterfly late last year. Somebody who got access to test deployment credentials managed to leak production data because they were working with production data in testing deployment, which is kind of a no-no. So, how can we do risk prevention in the cloud? First of all, we're gonna talk about, we have 4 topics. We wanted to address 4 topics. We wanted to address general secrets, I mean a database connection string, maybe a special configuration, a private one, maybe some IPs. You have sensitive production data, credit card numbers, personal identifiable information data, etc. You have encryption keys, cryptographic keys, and you have identity. And the first one is how is it recommended to manage your secrets in the cloud when it comes to a test CI/CD, testing deployment versus production deployment. The best recommendation would be to use a dedicated secrets manager with different values of secrets for testing and production, and only hold in your container the client ID and client secret for accessing the secrets manager. Don't pass the secrets, the double connection strings or other stuff, through environment variables, through the Docker configuration file, or other means. When it comes to sensitive data, you probably wouldn't want to be one of those companies with production data leaked to developers. You have a lot of incidents with internal breaches. So it would be recommended to have the testing data be a consistent replica of the production data with no real meaning inside. And unfortunately, there are some situations, especially in banks, in banking, where avoiding the use of production data is challenging. And you have complex debugging scenarios when you must use some testing data, or it's harder, you didn't plan it from the beginning, and it's harder to replicate at that point. So, if you really have to use the same database or data, you should take some measures. You should have different credentials. I know it's basic, but come on, don't kiss him. I know it's basic, but you would be surprised. I asked some friends, developers at other companies. I found a situation when they use the same credentials in testing as in production. Also, if possible, enforce multi-factor authentication on using these credentials and on the delete operations, especially on the highest level of sensitivity on data. Use strong encryption and dynamic tokenization of data. And we'll go into details into some of this. What would be considered strong encryption? Having your data scattered all over the cloud in different regions, also on premises, working with both on-prem storage and one database there and one database there, or a bucket there and a storage there, another storage there. You should be concerned not only with the data confidentiality, but also with data integrity. And above data integrity, these days, you should also protect the integrity, not only of the sensitive data, but also of the timestamp of signing. You should employ secure timestamping, and also of the encryption context of the data. The encryption context being the location of the data, so that if they steal the data and they don't get your key, but maybe they get access to the decryption server. If they try to decrypt it from another place, it fails. This is how it works. Let's say that I don't use encryption context. You have the dummy data and the sensitive data, both encrypted. I switch them, and the decryption server decrypts it. But if I use the location of the data, in this case the database ID in the encryption process, the decryption will fail.
Okay, so how can you manage to do the integrity of the data? How you can do it? First, you have the unencrypted document, you have the timestamp, and you have the encryption context. How you manage to put them all around to assure the integrity? First, you will make a hash of the unencrypted document, and then you will add the timestamp and the encryption context, and make another one to assure the integrity and also the confidentiality of the document. Probably you all know about tokenization and how it works. This is a really basic flow, but what we wanted to show you and what we wanted to highlight, it's about the token server, how it works, the token server. Basically, if the token server gets two requests, one from an allowed user and one from an unallowed user, you will, for that user who is allowed, you will get the real token because that's how it works. And for the user that is not allowed to request that token, you will get a masked data and you will not use it further.
Fun fact, I don't know if it was okay for us to mention that. If you search Google for some banks in Romania, who are, you will find two examples of banks who received above 100,000 euros fine, GDPR-wise, because they use production data in testing environment. Okay. There are some other factors to take into account when you think about the security of the sensitive data in your overall architecture. You should also, you have intentional storage, okay? You store your data in buckets, on premises, in databases, but you should also take into account the unintentional storage, which comes with an intentional logging, misconfiguration-wise, and or sending the access token or the refresh token in the URL get params. Those are logged by the Apache servers. Also, if you have, let's say, a microservice, how do you pass the client ID and client secret for the microservice to log to the secrets manager you had here and get its secrets? Well, you can pass them in the Docker configuration file, which is in plain text. You could pass it through the environment variables. You pass them through the environment variables, but as you probably know, child processes automatically inherit the environment of the parent process. So if the parent process doesn't sanitize its environment before sending it, the child process might have access to some data which it should not be allowed to access. And a trend nowadays is to use centralized caching, in-memory caching. Such product is Redis, which is used by microservice architectures with shared tenancy. And it's a NoSQL database with the key document structure. And they say that they are not, this is an excerpt from their website. They say that they are not optimized for security, but for performance and simplicity, and they should not be accessed from the public access. They should not be public. And we were curious, what if we searched on Shodan for public Redis servers? Well, guess what? we found more than 2,000 public Redis servers, some without authentication enabled. Default, it doesn't have authentication, and the data is not encrypted. The data cached in Redis is not encrypted, and you could, if you have two microservices using the same Redis server, one microservice could list all the keys in memory.
I can speak to two microphones. You probably know what is etcd. It's a database server used by Kubernetes master, and the secrets there are stored in plain text. We found out that in the last versions they can support encryption, but it's not used default. So you are responsible for what you are doing there. We deep dive into this topic, and we search on Shodan for etcd public servers, and we get like 2,000 public etcd servers. And if you go with and use that command, you will find what they stored there. We thought about what will happen, what can we find if we look through all that servers, and after only first 100 servers, I don't know, I think the third one, the 31st one, we found some private keys. On the all 100, we found more than 100 private keys, along with more than, I don't know, 20,000 certificates or something like that. So you will need to be careful about this. Going deeply into the cryptographic key management, you need to protect the key all over his life cycle, from the creation of it to the destruction. You need to be careful how you do the rotation, how you do the revocation, and then the destruction of it. Some challenges come here when it comes to management of the cryptographic keys, and you need to think about the high number of keys when you go to a wider architecture. Let's say you will start from the two keys or something like that, but you will manage to have, I don't know, 1,000 of keys. And maybe there are some keys on premises, some of them are in some cloud. So you need to be careful how you manage to do this. Apart from that, you need to be careful about the protection of them and the availability. Speaking about the security, the physical security, on premises you have the HSM, the hardware security module, that you will work with it. So you have the access to that, you have a proper access, but if you use a cloud provider, let's say Amazon, you will not have the access, the access to the HSM. You will have it through the to the cloud, and you cannot go with a stick there to put it and work with it. So that's it.
In cloud, when you start a new product and you decide that you're gonna have a multiple microservice architecture, and you're gonna use, let's say, Amazon or Azure, and you're gonna encrypt data both on premises and in the cloud, you have a few options when you write your applications working with the encryption and decryption. Either you make a damn good flow when working with keys, your own management of keys rotation, keys revocation, keys invalidation for being able to decrypt previously encrypted data and stuff like that. And you store it somehow in dynamic memory or enveloped on storage. And you don't use a dedicated key management system and no physical hardware security module to store your data in, your key in it. Then maybe you decide that you should rely on the hardware security module, but still do the key management yourself. Or you could have a dedicated key management system, and which works with one or a cluster of hardware security modules. This is the scenario for the happiest version when you use a key management system, a dedicated one, and hardware security modules. First of all, how it works. The key management system there only holds logical keys, metadata about keys. The hardware security module stores what they are called the backing keys. These are keys which never leave the device and which are used to generate data keys. The backing key is never used for encryption. Only the data keys are used for encryption. Let me show you an example. Let's say this application wants to encrypt this document. What it does is it asks the KMS for a data key. The KMS generates a data key, encrypts it, envelopes it with the backing key, sends back to the application both the encrypted and unencrypted version of the data key. The application uses the unencrypted version to encrypt the document and then deletes the unencrypted version and only holds the encrypted version of the data key. So the data key is never stored neither here nor there. And when the application needs to decrypt this document, it only has to ask the KMS to decrypt the encrypted data key. So the storage of the data keys is decentralized with the microservices around the world, whereas the master keys are managed at the KMS. And when the KMS needs to rotate a master key, what it does, it doesn't change the ID which the application knows, the ID of the logical master key. It only stores enveloped the backing key and generates another one. So there are advantages when working with a dedicated key management system. You have centralized management in a deeply complex application, multi-cloud application. It is only in one point, all the important, the master keys are rotated, are deleted, are stored, are protected. You have decentralized storage for data keys, and not having one entity be obliged to store a huge number of data keys, you could have an application use a high number of encryption keys and have some part of storage encrypted with one data key, other part with another data key, and so on. And if somebody manages to decrypt, to have access to one data key, they can only decrypt a small part of the sensitive data. Okay. Okay, so this would be, let's say, an overview of what can happen. You have on-premises where you have Active Directory, identity management, you have, let's say, some cryptographic keys, you have a storage, and you also use the public cloud where you have the identity access management from the cloud provider. You have some access tokens, you have other cryptographic keys, maybe some storage, maybe a database you use from your microservice customer management. And in the business medium nowadays, it is of high importance due to GDPR, due to the California Privacy Act, which will be enforced in January next year. And due to overall data protection, it would be okay for you to shift security left in the production process and take it into account at every level. And when you start with one microservice and one Docker station on premises, take into account that maybe in 2 or 3 years you might be scattered all around the world, and you are accountable for the security of your data and your customers. So we have talked about secrets management just a bit, about data protection, we tackled it a little, and about a small amount about keys management, both in testing and production environments. But the heart of it all is the identity access management. It is the single source of truth. The whole architecture trusts what the IAM says. Let's, before going into some topics like federation, access tokens, and stuff like that, we thought that maybe we should make some things clear, in case some of you didn't run into them. A colleague of mine told me that in their interviewing process, it's a funny fact, they get to interview people from junior to senior, and some of them don't know the difference between authentication and authorization. Authentication is the user management, credentials management, sign up and sign in. It has nothing to do with permissions, whereas authorization regards only permissions. Authorization does not work with identity, only with permission policies. Also, when it comes to credentials, there are permanent credentials. These are stored somewhere in a database, and these can be revoked. And you have temporary credentials, which shouldn't, or their purpose is not to be stored anywhere, to be used as bearer. Who has this token can access all the kingdom. And these cannot be revoked. They only rely on expiration time. Okay. Cafe Press is a company bought at a huge amount of money by Amazon, maybe?
Or Facebook.
It's, I don't know, it's a company which customizes t-shirts. But well-known, a popular platform. This summer, they were hacked, and their product enables users to log in through 2 means, either through Facebook, Google login, so federated, external federated login, and they also have some in-house identity management. And when they were hacked this summer, those who used federation to log in were safe. The others, in the number of 23 million and more, who were in the in-house identity management system, were hacked. Their PII data, personal identifiable data, username, passwords, were dumped. Okay, so before we go any further, I want to explain you what an identity provider is. Maybe some of you know, maybe some of you don't know, and what federation is. But before explaining what federation is, you should know what an identity provider is. I don't know how many companies, mostly do employee identity management, and customer identity management. I don't see that there's most of them, I don't think they have single sign-ons or centralized customer identity management. They have probably a database, customer database for the desktop product, a customer database for the web product, a customer database for the mobile product. Regarding employees, you log into your laptop through Active Directory, okay. And maybe there's an internal platform you use for testing, and you have a database made by the programmers with other credentials other than Active Directory. Or maybe you don't have proper integration with the Active Directory and you pass through LDAP, LDAP, the identity, Active Directory identity through your in-house application, which is not okay because you have to pass it unhashed and encrypted. And maybe you have another platform used in-house where you have other credentials for your employees. The proper architecture would be to have centralized identity management. Centralized management for employees and centralized management for customers. There should be only one identity. And if somebody wants to log into an internal product, it should be redirected to the Active Directory Identity Manager and receive an OK or denied from that. Also, if a customer logs in, let's say, in the mobile product, it should be logged in for a limited period of time until the expiration is hit into all the other products. What is federated identity? When you have, okay, let's say that you use centralized customer identity management. You have two options. Either you manage it in-house, you make your own management, or you realize that maybe you are a gaming product which has the purpose of implementing a game, not managing user identities. Maybe you want to gain and to gather user profiles, but you don't want to have a headache from managing credentials for the users. So, better and more scalable for you, it is to use external identity providers, which you could trust, Facebook, Amazon, Google, and have them have all the headache with the users logging in, and you authenticate with the external identity, and then you receive a grant from the external, an OK from the external identity, and you go with the OK to your gaming application, and you can use it. An advantage would be that this architecture is more scalable, because let's say overnight you have a 300% customer increase. You don't have to worry about, oh, this is a small database, it's not properly managed, I was not prepared for this, too many requests, stuff like that. They have to handle that. Short context about how federation works when you go to a federated identity provider, either public or custom, which you trust, would be, first of all, your application, which is a service provider, has to register with the authorization server, where the permissions are handled. So the authorization server, recommendable to be an external one. The authorization server trusts some identity providers, Facebook, Google. You register your application with the authorization server saying which identity you want to use, let's say just Facebook, and you receive a client ID and client secret. These are like a username and password. And then, when the user comes and uses your application, first of all, he will go and log in with Facebook. Here, the application receives an authentication grant from Facebook. The application sends this authentication grant along with the client ID and client secret previously received to the authorization server, which is also called the token endpoint, and you receive back two things: an access token, which you will use from now on until it expires to access the resources, and a refresh token. This does not have an expiration time. This is a secret. You use it to refresh your access tokens when they expire.
I don't know if you're familiar, but last year Facebook was hacked and they managed to lose 50 million access tokens, and they were forced to revoke them. What happened actually is that from your account you were able to access another account, take that access token, and with this they managed to stall around 50 million access token. That translates into a revocation of them and making the users sent to log in again. What we want to highlight with this is that the fact that protection of the access tokens is vital and really, really important. Starting from that, we want to speak about access tokens regarding the application logic and where you put it, where we put it. You have two options. One of them is to put it on the server side. You manage all the things on the server side. The working with the tokens goes there, and in the client side you don't need to use the access tokens, but there is the client side applications like Facebook where you need to have access when you need to work with the access tokens. But remember that anything that goes on the client side is called as public. So, I don't know if you're familiar, but with Chromium Embedded Framework, basically it's a trend nowadays to work with it because it's easier to render HTML pages into applications. The interesting fact is that this framework, this library, is not served as a black box, and you can manage to modify as well as you want. So when you are receiving an application that works with Chromium Embedded Framework, it is your responsibility when you are going into the client side to manage the access tokens, and you need to protect them. One suggestion we want to tell you, it's about using an intermediary token. Basically, it has no sense, let's say, in the client side, and the only property of this token is when you are going to the backend, it replaces with the actual token, the real token that works with, let's say, with a microservice.
Another idea would be to use front-end encryption only in memory. Let's say that you are an application which really needs to make requests to a public web service from the front end. You created your application like that. An idea would be so you receive the access token, which you're gonna use to access the public web service. When you receive it with CryptoJS or another cryptographic JavaScript library, you generate an encryption key, which you don't store it on the local storage. You only hold it in a variable. You encrypt the access token with this encryption key. You hold it encrypted. And whenever you need to make a request, for a short period of time, you decrypt the token, send it, and immediately encrypt it and immediately delete the decrypted version. And whenever you have to do this process, you just decrypt it, send it, decrypt, delete the decrypted version. And when the token expires, let's say in an hour, and you receive another token, you delete the current key, you generate a new one, you encrypt the new token, and you go again in the same cycle.
Another aspect about access tokens, it's regarding the storage of them and also the transportation. Speaking about the storage, in the backend, you can store the access tokens on the session cookie. It's safe. But if you go to the client side, the only way to secure the access token is in the HTTP only cookie. If you want to store the access token in the local storage or in the cookie, you are not safe to do this. It's not safe for you. And regarding transportation, you should never use the get URI params, and you always need to send them through a secure channel.
I'm going to be fast. We have about 5 minutes left. You could have, when you have an architecture working with federation, single sign-on, and tokens, you could have an architecture in which you start with signing in here, you get an access token, you sign in with that token to a secondary service, you get another access token, you sign into a third service, you get another access token, and what gets back to you is the third token. And when you have such an architecture, you must take into account the refresh flow and the revocation strategy. They created a refetcher for revocation in the past 2 years, I think. Revocation means you cannot revoke access tokens. They are not held, they shouldn't be held in a database. It's not their purpose. They have an expiration time, usually short. You set the expiration time. And when you want to, what you revoke is the refresh token you use to get another access token. You have to take into account how you're gonna revoke all the refresh token downhill so that when you revoke the first one, all of them will be automatically revoked. Remember Facebook? They had 50 million accounts leaked because you could get an access token from, you went on a Facebook page, you took advantage of some bugs, you got the access token of another user, you went to the page of the join user, you get the access token for Mary from there, and so on. And they were able to revoke in a short period of time 90 million tokens. Which proved a good strategy for them. And believe it or not, there are applications which, out of commodity, don't set a proper expiration time on access tokens. They make them permanent passwords. Okay. The last topic is something I personally like a lot. It regards the IAM strategy at the company level. Some principles which we don't see employed more commonly. First of all is the unified employee identity management I talked to you about. Secondly is the unified customer identity I talked to you about. Thirdly, when it comes to permissions, use the principle of least privilege with the default on deny. AVS does it well when it comes to that. When you have a resource in the cloud, by default you are denied. If you don't explicitly allow access to that resource, it's by default denied. Also, if possible, try to avoid to use permanent credentials. As much as possible, use temporary credentials and roles. Have user, if somebody wants to access the cloud resources of another account, don't give them credentials to the other account. Have them be able to assume a role which translates into a temporary credential. And if the case, enforce to prevent situations where credentials are leaked, enforce multi-factor authentication. They don't have the device, either hardware or virtual, so they cannot use the credentials to elevate to those roles. You also have cloud trailing. This is logging all the API calls done in the cloud. Okay. And an interesting fact is the privileged accounts. Privileged accounts are the root accounts, those which cannot have their permissions trimmed. They are the god of all. And who has the root account has access to all the resources, to all the users. Common practice is to have the root account, the privileged account, always on. 24/7, always on, always enabled, although it is not necessary. A good practice would be to have true just-in-time privileged account management, which means that the person which has the root account credentials is created a normal user, usually uses the normal user credentials, and when in need, it elevates based on multi-factor authentication to the root account credentials. And instead of having an attack surface permanently available, you have shorter periods of time when you have the privileged account exposed.
For those of you who are interested about machine learning and how can you apply machine learning into authentication, basically you collect all the information, and based on a score you'll make, you can ask for a different type of authentication.
It was Google. Google uses. They have a patent on adaptive authentication.
On mobiles.
It makes customer experience simplified. So whether you're asked for two-factor authentication or you just receive a one-time magic link on your email. Okay, so as a conclusion, I told you that this is a wide subject. I told you that we had a choice to make, either for this presentation deep dive only into one topic, which we're gonna do in the next one. We want to deep dive into federation. Or try to make a more general presentation and try to tackle some things you see done wrong in businesses nowadays. Don't forget that all the major cloud providers offer you shared responsibility. But shared responsibility doesn't mean that they have to protect your data. It means that they are responsible for the product as a service they offer, so that the input you give them is properly sanitized and processed, and the output they offer you is reliable. But what you do with that output is your responsibility.
That's it. Thanks.
Thank you, Raluca and Cristian. Thank you. So we'll take some questions. Okay, so we have one there, second, Razvan. Just a moment. Okay, Jay, yeah, you are next. No, that is the first guy.
Okay, so I saw that in order to grant access to resources, usually you compute that risk score, and as an input to that, you have the user identity. But what about the device? How you take the device and the status of that device and the health of the device into account in order to compute the risk score, and think about having not only the identity of the user in the mix, but also the device as well?
Comes to adaptive authentication.
Yeah.
Well, there are methods of scoring. You do scoring. This is how you categorize the users. You can do scores based on geolocation. You can do scores based on the UUID of the device. You can do scores of how that device you have and the operating system on it are graded, are scored themselves. Some operating systems are more trustable, more trustable. Some are not. Devices also, they come with firmware better protected or default with the password 000 on. Jay can tell. Yes. It is a complex structure, a ton of informations you have to take into account.
Yeah, but for that, do you recommend, or the strategy would be to have an agent on that endpoint and to collect all this information, or how that work? I know that you need to take into account the status of the firmware, the hardware, firmware, software, let's say,
of course, you have an
last time the antivirus run, and etc.,
yes.
etc. A lot of tons of data, but in order to get that as a feed to the risk score process, how's the communication working between the endpoint device and the policy engine that does that?
Of course you have an agent there collecting some data. Either you couldn't communicate. How do you communicate with the backend?
Thank you. We have another one here.
Please.
I was about to...
Please speak clear. I couldn't properly hear back there. Speak clear, louder.
At some point during
you.
your presentation, you spoke about in-memory data stores and Redis.
Yes.
And I wonder if you are aware of some similar solutions which offer some sort of data encryption features. So that's my question basically.
It depends on what kind. I'm used to Redis. I worked with Redis as a service. If you use it as a service integrated with the cloud provider Azure, for example, it offers some security in place. But if you decide, the talk was about public servers. And there are some solutions oriented towards security, better security, and which compromise with performance. And other solutions which don't compromise with performance and compromise with security. You can't have them both properly done on the hardware nowadays and the architectures nowadays. So it is your decision to see what do you want best and where you can place it. You could have, if it was my decision and I should have performance on data caching, I would use a private service behind a public service. It wouldn't go online, my in-memory cache server.
Okay, thanks.
You're welcome.
I'll just ask you offline. I mean, I don't want to take too much of your time. You seem to be very important over there on stage. So.
Okay, we'll take one more. Let's see. Okay.
But speak loud, please.
Right.
The echo is...
At some point, you mentioned that you would use federated services with Google or Facebook to authenticate your users. At the end of the day, the onus lies on you. If you use a third-party service and they get into a problem, for whatever reason, the data is leaked, your data is reliant on that. Why would you use that? Why would you? So we always recommend using federated services from your own database.
You have two methods of doing federation. Either you use from your own database, the integration with SAML, and there are architectures when you need to log into the on-premises database. But this is for accessing resources mostly, in-house access of resource of the application, and you use the local LDAP, let's say, or Active Directory. And there are some other situations when you want to federate through OpenID Connect and use web federation. And
right. So this is, sorry to talk over you, but this is what we do. If we have an application in the cloud, and we are an IT company, so we work with different providers or different customers, we would have a login, which is for users, and LDAP will authenticate that. If we then have external users who want to then come in, we create another database in another location, federate that access.
It's your choice.
It's a safer option, is it not? Compared to using Google or Facebook?
If you do it properly in-house, yes. If you don't do it properly, if you're
I see
an
your point.
account finance application which doesn't know how to properly manage identities, it would be better, it's safer with Facebook, I would say. It depends on your architecture.
Thank you.
If you're, let me tell you something. You could use, for example, if you integrate with infosec cloud, if you're that good of a business which can afford Amazon Cognito, you can use their identity, both identity, user, and authorization solution, which does all the work, is their responsibility.
Yeah.
And if something happens, they're accountable. You are not accountable, but you would have to afford to be able to use Amazon Cognito. And you can integrate with Amazon Cognito, both with Web Federation through OpenID Connect and your own enterprise federation.
Oh, perfect. I didn't know about that, but thank you.
Okay, look to Amazon Cognito.
Thank you.